We are going to begin this video by looking at the properties of ionic compounds and also looking at metals and how they bond. We will look at covalent bonding in a whole unit of its own since it has quite a bit to say about that. So we'll start with properties of ionic compounds. First of all, most ionic compounds, when the two elements, the metal and the nonmetal, bond together, they are crystalline solids at room temperature, so most of them are solids, and they have a very high melting point, and that's because of the really attractive force that's holding that metal with the nonmetal. Remember, one's giving away a valence electron, the other one's gaining a valence electrons, so there's a really strong attraction between those, and in order to melt that solid, you would have to have a very high temperature for it to be warm enough or hot enough to break the bond holding those metal and nonmetal together. Another piece of information about ionic compounds is each element that makes up an ionic compound has a coordination number, and that's just the number of ions that surround it in the crystal. So for instance, if we go back to our sodium chloride example, we have if we were to take a look at one of these ions, maybe this one, and look at how many of the opposite ion is around it, you would have 6. There would be 6 of those. And because there's one sodium for every chlorine, if we took a look at one of the purple ones here and took a look at how many ions were around it, it would also have 6. So sodium and chlorine have a coordinate number of 6. Now this isn't something that you're just going to know necessarily. This is something you would need to see the crystal, be able to kind of count how many there are. Now, some other characteristics that will be on your test is that ionic compounds can conduct electricity, but not when they're solids, only if they're melted, so they have to be a liquid, or if we took the solid and dissolved it in water and then we tried to pass electrical current through it, it would pass electrical current, and the reason for that is because of the positive and the negative charges. So the cation, the positive charge, can move from one electrode to the other, and they can move back and forth, so it kind of finishes the circuit, which allows the electricity to flow through that. The ion movement is what allows that electricity to flow. So that's really important because as we get into bonding metals, the movement of those positive and negatives, the movement of the ions, is what allows electricity to flow. So if we take a look at metals, we know that the valence electrons of a metal, they're mobile. They drift, they can separate from one another, they don't stay very well necessarily in orbitals like we've talked about. So when we look at metallic bonding, okay, two metals that have bonded together, we are looking at these little negatives right here, all right? And notice that the negatives, because your positive is inside your nucleus here, the negatives are moving around. So you have all these arrows. So these electrons can freely move about anywhere within that metal. And the attraction of those free-floating valence electrons for the positive charged metal is what creates a metallic bond. So those electrons just can freely go to whatever positive nucleus they want, and that creates this metallic bonding. Metals have a lot of properties that we know. For instance, heat can travel through them. They conduct heat very well. So if you add heat to a metal like here, those electrons, you can see the little arrow moving here, will speed up because of the heat that is associated with them. Because they can move freely, they can pass heat, so that you're going to feel that that hot increase in temperature on the other side of the metal. It's probably why you don't use a metal spoon when you're cooking. You usually use wooden or something with a plastic handle so you don't burn yourself. Also, we know that we can hammer metals, and so here's an example. If you were to hammer the metal, it doesn't break. Notice that it gets pushed inward. They are malleable. You can hammer them, bend them, so on. And that's again because those electrons, because they can free flow and free move, that can force the metal and those positives to also move with them, and that they don't shatter. So we said that they can conduct heat and electricity. Again, that's because of the free flowing electrons. They are ductile or malleable. Ductile, they can be drawn into wiring. Malleable, you can hammer them, bend them without them breaking. Again, that's because of the electrons. And metals are crystals, and they're also arranged in very compact or orderly patterns. So it reminds me of when you go to the grocery store and they kind of stack the apples, or the oranges on top of each other so they don't all roll off. You have your positive ion here, and then the free-floating electrons can just kind of form like that in-between layer there. And so they're very compact, very tightly packed together, very orderly. If we take a look at alloys, we hear about alloys a lot. This is a mixture of two or more elements, and at least one of them has to be a metal. We had sterling silver. Sterling silver is not actually on the periodic table. Silver is, but when we say a piece of jewelry is sterling silver, it's actually a mixture. It has silver and it has copper, so it has two elements mixed together that makes it a mixture. And alloys are important because their properties are usually superior. They're usually better than just the individual element themselves. So sterling silver, property-wise, it doesn't get that, not rust. Silver doesn't rust, but it gets this layer of stuff on it. It oxidizes, it reacts with the oxygen in the air. Sterling silver doesn't do that. So its properties are better than just the individual elements by themselves. Steel, for instance, is the probably most important alloy today because we have so many varieties on how we can use it. We have stainless steel people use in cooking. They also have stainless steel refrigerators and stoves and all these things. We also have surgical steel, completely different. It has different mixture to it, but it is used obviously in surgery so that it can maybe help protect against bacteria growth and things like that. So each type of alloy has its own unique property that is better than the individual elements if they were by themselves.